The basics of probability. Come on. When was the first time you learned about probability? Elementary school, right? You toss a coin, a fair coin. What's the probability that it shows heads? 1/2 or 50%, right? But we're not going to have problems that easy, right? So, the probability of any event occurring, that's how we write it. It's always going to be a number between 0 and 1 inclusive. You guys know that, right? If the probability is 0, that means it's never going to happen. If the probability is 1, that means it will happen with certitude. Right?
Yes.
But usually it's going to fall somewhere in between there. I don't think I'll give you problems where the probability is 0 or 1. Okay, so let's start off easy. What happens if I toss a coin 2 times? Wait. You guys learned this in biology, right? When you having birthing boys and girls. Can you guys do that? Oh. Yes or no? Like if you have 2 children, what's the probability of getting 2 boys? Simple probability. So same thing, if I toss a coin 2 times, because the probability of getting a boy or a girl is about 0.5, right? So if I toss a coin 2 times, okay, let's just do this. What can happen when you toss a coin 2 times? You could get head, tail, tail. Right, let's write out all the possibilities. This is just like making a truth table, right? Remember? How did I know there's going to be only 4 possibilities? Because when you toss a coin, there's only 2 possibilities, heads or tails. So when you toss another coin, there's 2 possibilities, right? 2 times 2 is 4. What do you call it when you write out all the possibilities? This is called
line list.
A list of all the possibilities is called the
Sample set.
Space. It's in the notes, for Pete's sake.
Did we do this?
Yes. Plus, in your pre-algebra book, I'm pretty sure they use those words, sample space. There's a listing of all the possible outcomes. So in some of the problems tonight, if you just write out all the possible outcomes, the sample space, it's so easy to do probability. So whenever you toss a coin 2 times, since there's 4 possibilities, the answer is going to be something out of 4. Because there's only. So if I toss a coin 2 times, what's the probability of getting 2 heads?
1.
Yeah, there's only 1 time that happens, so 1 out of 4. What's the probability of getting 1 head and 1 tail? 2 out of 4. What's the probability of getting no heads? Which means tails. I'm pointing at 1 out of 4. If I add all of these numbers, it comes out to 1. How come? Because that's everything. That's all the cases, right? Shouldn't they all add up to 1? Because one of these things gotta happen. Okay, what happens if you toss a coin 3 times now? How many elements will there be in the sample space? Times 2, just like the truth tables. 8. Okay, let's write them all out. Do it out. See, I like to do it alphabetically so you don't miss any. H, T, head, tail. So that's the sample space when you toss a coin 3 times. There's 8 things, 8 possibilities, so you know the answer is going to be something out of 8. So you toss a coin 3 times, what's the probability of tossing 3 heads? Out of 8. So you just count after that, right? What's the probability of getting 2 heads? Let's count. 3 out of 8. What about 1 head? Out of 8. What's the probability of getting no heads? Which means all tails. 1 out of 8. And of course, if you add them all up, you better get 1. And they do. Hey, Mr. Parker, I'm seeing a pattern. Pascal's triangle. No. 1, 2, 1. 1, done. How can you guys not see Pascal's triangle by this time? So, so when you get more sophisticated, what if I toss a coin 7 times? How many elements are there going to be in the sample space? 7, which is. Now, do I really want to write out all 128 possibilities? No. So this is where you got to think. See, the denominator is always easy to figure out. It's the numerator. So I toss a coin 7 times. What's the probability of what's the probability of getting 3 heads and then 4 tails then? Okay, look. This is the probability of getting 2 heads, 1 head, heads, 3, 2.
Are attended by a skilled
So what number goes on the top? Now remember, in Pascal's triangle, in the second row, these numbers here, this is 2 choose 0, 2 choose 1, 2 choose 1, 2 choose 0. 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. So in the 7th row of Pascal's triangle, will be 7 choose 0, 7 choose 1, 7 choose 2, 7 choose 3, all the way to 7 choose 7. Maybe if I write it out for you, look. Maybe if I write it for you, you can. Okay, so this is the probability of getting, what did we say? 3 heads, okay, 0 tails. This is the probability of getting 1 tail. This is the probability of getting 2 tails. This is the probability of getting 3 tails.
How many coins did you put?
7.
35.
So what's the probability of getting 3 heads and 4 tails?
35.
7 choose 3. Well, it just depends which direction you're going, right? But it doesn't matter because 7 choose 3 is equal to 7 choose 4.
There's not 35?
7, 6, 5 over 3, 2, 1. Yes, it's 35. 35 over 120. Oh my goodness! Are we going to have problems in this chapter?
Yeah.
Well, I hope not, because I mentioned in your comments about how difficult the 4th quarter is. Because this first chapter is not that difficult, but then once we hit the next couple chapters, they're going to get pretty hairy, you know. Okay, let's kick it up a notch. Let's roll a die now. You guys know what a die is, right? A standard die. 1 through 6, Monopoly. If I roll a single die, what's the probability that it shows a 4? 1, 6. Okay, but you're never going to get a problem that easy. Let's roll 2 dice now. What's the probability that the sum of the 2 numbers showing is, say, 7? How do you know? Huh?
It's, you can make a table.
Ooh, where did you see the table?
I don't remember.
Notes, perhaps? SAT prep, perhaps?
Yeah.
In your pre-algebra book, perhaps? Yes, okay. Anybody who takes probability, you have to see this at least once. If you were in my summer school class, I showed you your pre-algebra teacher probably showed you too. Okay, what can happen when you roll 2 dice? What can happen? You get a 1 on the first roll and a 1 on the second roll. Writing them all out. So basically we're writing out the sample space. Now it's kind of cumbersome, but you have to see this at least once in your life. I put this in the notes.
Yeah.
Yes. Five and 1, 5 and 2, 5 and 3, 4, 5 and 5, 5 and 6. 1, 6, 2, 6, 3, 6. How many elements in the sample space? 36. So whenever you roll 2 dice, the denominator is going to be 36. It's always going to be something out of 36. So what's the probability that the sum of the 2 numbers showing is 2? In other words, snake eyes. Right there. 1 out of 36. What's the probability that the sum of the 2 numbers add up to 3?
2.
There. 2. So 2 out of 30. What's the probability that the sum of the numbers is 4? What about 5? 6, 7, 8, 9, 10, 11, 12. I see a pattern, Mr. Park. No, it's on the diagonals. So what's the most common roll when you roll 2 dice? Rolling a 7. And what's the probability of that happening? 6 out of 36, because that's the longest diagonal. And that's why, you guys know how to play craps? You guys ever heard of the game craps? That's why 7 is the key roll when you play craps, because it's the most common roll. Out of 36. Whereas if rolling a 2 or a 12, those are the least common. 1 out of 36. Probability of that. So we can extend this now. Oh, so we can, of course this is honor, so we can get up on that. Let's roll dice now. Now, do I really want to write out the sample space for now? No, but what's the denominator going to be when you roll? 6 times 6 times 6. 216. So I roll 3 dice. What's the probability that the sum of the numbers is 3? We'll start out with an easy one.
1.
What's the only way you can get a 3? A 1, 1, 1. That's it, right? 1, 1, 1. That's it. So 1 out of 216. Simple. What's the probability that the sum of the 3 numbers is 4? Out of 216. Well, how can you get a 4? This is what period is that 4 or 3? You said 0, 4, 4. No, 0, 4, 0. You can't roll a 0. 2, 1, 1. But then you can put that in different orders though, right? 1, 2, 1, 2. Is that the only? Yeah, so 3. What's the probability that the sum of the numbers is 5? Okay, how can you get a 5?
2,
3, 1, 1. Okay, but how many orders can you put that in?
3.
Yeah, because just think about it. The 3 could have gone here, could have gone there, or could have gone there, right? Or think about it as a 3-letter word. How many 3-letter words can you make with like 1 A and 2 B's? Is that the only way?
1, 2.
Well, okay. Orders can you put these in though? Look, the 1 could have been here, here, or there. 3. Any,
No.
no. So 6. I see a pattern, Mr. Park. What's the probability that the sum of the numbers will equal 6? Okay, let's write it out. How can I get a 6? A 2 and 2 and 2. How many different orders can you put them in though? There's only one order, right? What else? What about 1, 2, 3? But how many orders can you put these in? 3 factorial, which is 6. See how you're using combinatorics here? Any other ways you can get a 6? 1, a 4, 1, 1. How many orders can they be put in? 3. Anything else? No. So add them up. 10 out of 216. I see a pattern, Mr. Park. Come on, the other class got it after 3. This is period 6, supposedly the smartest. 1, 3, 6, 10.
The triangle.
The triangular numbers. I'm telling you, they're going to come up over. Just wait till we get to the later chapter. You're going to know the triangular numbers. So, knowing the triangular numbers, what's the probability that the sum of the numbers is going to be 7 then? 15 out of 216. You guys even remember the triangular numbers? Why is 1 a triangular number? Because look, it makes a triangle. What about 3? Oh, it makes a triangle. What about 6? Well, if you add 3 dots, it makes a triangle. You add 4 dots, it makes a triangle. You add 5 dots, it makes a triangle. They call it numbers. Now, what was the formula for the triangular numbers? What? Do you remember when we we studied the
1, 2,
binomial
3,
theorem,
4,
and I
5.
told you you better know it for the test, and it was on the test. And Takaki? Two. Formula for the triangular number. You're in deep trouble. Okay, so the beginning problems of tonight's homework, just write out the sample space, you can do it. Now, after a while though, when the problems get harder, you don't want to write out the sample space. So then you start using common authority. Here, how come we finished early? Actually we didn't. The bell's gonna ring in 1 minute. Just try your best, and then tomorrow